So you want to create new files to have enough free space, but you're getting not something like insufficient disk space message. So you are trying to create new files to have enough disk space, but you are getting not enough disk space message or something of that sort. This is why. Oh yeah, welcome to Linux Quickie episode 1. Much more to come. Like, subscribe, and hype to get notified. So you are watching my diagnosis. So this here I'm going to show you what's causing that and things that can drive that and all of that sort of thing. If you're watching this in a short form, come and check the long form video. I'll see you there. For the long form peeps, well, this is the explanation, okay? So basically I have here two test storage spaces. This one was formatted with XFS. This one was formatted with ext4. Okay. So I can prove that to you, so I can do -blk -fs. There you go. This is formatted to XFS. This is formatted to ext4. Okay. So let's focus here on the XFS one. I'm doing the df-i, and I is going to show us the inodes. And in a very short explanation, when you create a file, you take an inode. When you create a folder, you take an inode. It's a little bit more complicated than that, or than this, but that's kind of the nutshell. So every time you create a new file or folder, inodes are consumed. Basically, that's that. On the inode, there are many properties stored of that file or folder, like file names, permissions, properties, file sizes, location on the storage, etc. So basically, an inode, each file needs an inode to exist. They are usually linked. The binary data and the inode are usually linked to one another. Doesn't matter how, they are linked, which means sometimes you can delete the file, the inode is still there, which means that the system thinks the file still exists. Or sometimes you delete the inode, but the file is still there, and the file does not exist, even though it exists. That's a different story. Let's focus on what this Quickie is about. When you create a file or folder, inodes are consumed, okay? And sometimes you have enough physical space on the storage, but not enough inodes. Sometimes you consume more, you consume all the inodes, like many small files. So you consume all the inodes. You still have lots of space available on the storage device. You cannot create new files because you have run out of inodes. It's a rare occasion, but it may happen. So that's one of the reasons why you have different file systems. Like, for example, XFS and ext4, which are the two most common ones nowadays in Linux. Okay, and I'm not going to discuss here anything specific, just very generic file systems. Okay, so here you can see that on my XFS drive, you have here I have here the number of inodes available, the number of inodes used, and of course the number of inodes free. So this is these are two. They are just created and formatted. I have nothing there, like you can see here. They are empty folders, empty partitions, just created and formatted and mounted. As you can see on XFS and on a fresh XFS system, I have this amount of inodes used and this amount of inodes used in ext4 system. Okay, so as you can see here, the partition sizing is exactly the same. Partition size is the same for both. Kind of the file system sizing, it's similar because they are different file systems, which means they're going to be treated a little bit differently. All right. So this is what you get after being formatted, and these inodes reservations, or these inode reservation are created when you create a partition, and of course when you formatted it. So this is the physical size of the partition, all right? This is the sizing, and this is the sizing and the inodes created, all right, after they're being formatted, because inodes are managed by the file system, not the partition size. So after formatting XFS a 2.5 gig partition, this is the amount of inodes that we get, okay? When on XFS, on ext4, this is the amount of inodes you get when formatting with ext4. So as you can see, sizing is very similar. Of course, physical size is exactly the same. After formatting, the sizing is slightly different. And the main difference here, which is the purpose of this Linux Quickie, is this is not cannot be that as quick as I wished, but doesn't matter. For this Quickie, you'll see that the inodes created for the same partition size is much larger on XFS than it is on ext4, which means same partition size, same size after formatting, different amount of files you can create if you are using XFS or ext4. Okay? If you run out of this number, okay, you cannot create any more files or directories, even if you have free space. Okay? Even if you have here available space 60%, for example, if you have run out of inodes, you cannot create new files. So free space is one thing. This is the physical space available on a partition. Okay? But if you run out of inodes to assign to each file, you cannot create new files. You may have free space on the partition, but you cannot create new files because you have run out of inodes. So let's make this really simple. 1-to-1. One file, one inode. Okay? If you create, in this example here, rough example, if you create, I didn't even count this, 1, 2, 3, 1, 2, 3, okay? So you can, a million, right? This is a million, right? You can create this amount of files. So you can create this amount of files if you do this purely 1-to-1. You already create, it's a million, right? My brain just brain farted. A million, isn't it? It is. You can create a million and 1.3 million files, okay? If you run out of these numbers, if you create this amount of files, but they are very small files, which means you will have available free space on the partition. You cannot create new files because you have run out of inode numbers. You cannot assign an inode to a new file for that file to exist. You have free space, but you have run out of inodes. For example, you need to give each file an ID card. This is a limit you have. We have this limit of ID cards. You assign all the ID cards. You have space on your country. You cannot receive more people because you have run out of ID cards. It's a rough example, really dumb, but you get the idea. So one of the reasons why you should choose XFS over ext4, it's the amount of files you can create in a single partition or storage device. And this is calculated at the creation time. Okay? So when you create a partition and you format a partition, this number is assigned according to the partition size. Okay? And this is something which leads me to the question, if I extend the size, will the inode numbers increase? Let's find out. Okay, I did some resizing. All right. So now the ext4 partition went from this big to this big, and the XFS partition went from this big to this big. A simple resize, and you can see the comments here. Okay. This was for the ext4. This was for XFS. Then I just did the resizing with the growfs and the resize to fs. Okay. This is not a video about this. This is just to show how it was done. Now I do the f-h, and they are both bigger. And let's do the minus I. And the inode number now is, if you check this out, so 1.9 in the case of XFS, 245 in case of ext4. So let's compare. So this is what we get. This is the after. After XFS and after ext4. Now we pull up when they were smaller. So let's scroll this up. And you have 1.3 for the before. in the case of XFS, let's check the before. In the case of ext4, so 2.4, this number here. Okay, so as you can see, after the resizing of our partition using the LVM extend and the resizing using the resizing, the regular resizing stuff, the actual inode numbers were increased, which makes some sense, right? Which makes sense because if you increase the partition size, the inode numbers should be adjusted. So in this case, it was kind of the ideal situation. You get the free space and the extra inodes to play with. But this is when the kind of the be careful situation becomes really important, which is this may not be always the case. Okay? So in my case here, in this situation, we increased the partition sizing, we increased the file system sizing, everything went smoothly. We had more free space for files, and we have more free space in terms of inodes. So now we can create more files because the inodes were recalculated and increased. You cannot change the inode assignment without any type of resizing unless you get into some voodoo, but that's just your own prerogative to try. These are assigned and these are set up and configured on a partition when it's created and formatted. Okay, so you have to deal with that while the partition exists. In our case here, we extended the partition, we get more free space, and we get more inodes. Okay, which is kind of the ideal situation in this case. But friends, please take care. This is a Rocky Linux 9.5. The kernel is 5.14. This may not be always the case. May not be always the case to all file systems. May not be always the case to all Linux versions that you are using. In my case, in this example, I increased the partition sizing, I increased the file system size, and the inodes just were adjusted accordingly. Okay? And that's what we want to see. But be careful. It was my case. It may not be your situation. All right? But now you know how to tackle this. If going back to the very beginning of this video, if you are trying to create new files, you have free space, but you're getting disk is full or something of that nature, most likely you have run out of inodes. Do the bare minimum and do the df-h and check how many free inodes you have available. If you don't have any free inodes available, you cannot create new files even though you have free space. Your options are extend and see if you get more inodes, delete some files, restructure your file structure because many small files will eat inodes really fast, but won't eat that much free space because there are many small files. If you have a very specific need that is many small files, you need to tweak the inode assignment to each partition. Don't leave it to the automatic stuff. You need to tweak that on a file system and see if it's possible for that file system to tweak the amount of inode numbers are reserved different from the default. So if you have a very specific storage need, like many small files, like many JPEGs, many PNGs that are very small, you need to think your inode designation assignment. You know what I mean? So you need to think what storage type you will get on your storage. Many small files will need many inodes and not only free space. This was not that much of a quickie, but that's what you get, and it had to be done. I had this question pop many times recently in recent times. I don't know what people are doing, but many students and clients are just telephoning me and DMing me asking this, why am I having this not enough space available, blah 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 thing, and this is the cause. And I thought, let's document this and let everybody know what is the cause and how to deal with it, how to diagnose it, and how to troubleshoot it. Well, this was the first Linux Quickie. It was not that big of a quickie, but it had to be done with a bang. This is a major thing. Read, reread, and please experiment first before you dive into any extra steps. Like, subscribe, and hype. I really love you guys, and I'll see you in the next one. Cheers, guys.